How's it going, guys? Let's look at F15-3. It says here, a motor, there's the motor, exerts a force of F equals 20 T squared Newton on the cable. There's the cable. So there's F. Okay. Determine the speed of the 25 kilogram crate at T equals 4 seconds. The coefficients of static and kinetic friction between the crate and the plane are mu s is 0.3 and mu k is 0.25. Okay. So how do we solve this problem? Well, first of all, we have force information, we've got time information, and we want some velocity information. So we know if I've got these variables or this information, I can use the principle of impulse and momentum, right? So the initial momentum of the particle plus all the sum of all the impulses is the final momentum. Okay, so how are we going to solve this problem? So I think perhaps many of us, we would just say, well, okay, it's initially at rest. I'm not sure how you would solve this, okay? So we could say, okay, it's initially at rest, so V1 is 0, and then we could say, well, okay, it's going to be between 0 and 4 seconds, and we're going to have this force here, and then we're also going to have an opposing friction force, F friction, okay, and perhaps you're going down this road, you're on the right track, but the problem with this is, and perhaps you would say, oh, and then it's going to start moving, so it's 0.25 times the normal force, right, times 4 seconds is mv2. Perhaps that's what you were saying. Between 0 and 4 here for this applied force, and we have to subtract the impulse due to this force, the friction force, which is kinetic friction, over 4 seconds. Perhaps that's where you were going, perhaps not, so forgive me if I wasted your time. But we can't start from 0 here, and we can't use all the 4 seconds, because we have to find out at what time does this crate start moving. What time does the crate start moving? Or we can say is on the verge of slipping. Okay? So what happens when we're on the verge of slipping? We know that our static friction force is mu Sn. Right? This equation we know is only applicable when the crate is on the verge of slipping. So basically what is happening here, let's first calculate this and then I can come back. Fs is equal to mu Sn is equal to 0.3 times 245.25. Okay, that's the normal force, you can calculate that. And that equals 73.57 Newton. Okay, so this is the static friction force. What we're saying is this force of 20 T squared, it starts from 0, right? At time equals 0, this applied force here is 0, and it increases and it increases until it matches this force. And up until that point, up until that time, this crate is going nowhere. And only once it surpasses the friction force of 73.57 does the crate start moving. So these initial times and this time of 4 is wrong. Okay? We have to find the time when the crate starts moving. So all we do is we say sum of the forces in the x is equal to 0. Okay? Sum of the forces in the x is 0. So we're saying 20t squared minus my friction force is 0, and this friction force is 73, and if you solve for this you're going to get 1.918 seconds. Okay, so only at 1.918 seconds does this force from the motor begin to exceed the static friction force, and only then does it start moving. And that needs to become our initial time here, and we need to replace this impulse time by 4 minus 1.918. Okay, so this, what we're looking at is from the time that this crate starts moving, and so then this force is being applied only from 1.918 to 4, and this impulse of kinetic friction is being applied from 1.918 to 4. Okay, and then this mass here is 25, so the V2 is in the back of the book. Okay, I'm not sure what the answer was. Let me have a quick look. It was 10.1 seconds. Okay, 10.1 meters per second, I'm sorry. Okay, so I hope you get the idea there. If you don't, come see me. Cheers, guys.